So good afternoon everyone. Today we are going to discuss about semiconductors. Semiconductors is a backbone of all the modern devices like computers, laptop, iPad, iPhones. All things actually include semiconductor as its component. So why semiconductor is so much important? Because guys, as we know that we cannot control flow of electron in conductor and insulator, because conductor has abundance of free electrons and insulator has no free electron at all. So it is only device, semiconductor is the only device where we can control the flow of electron. And guys, if you can control over anything, you can win the world. Like if you can control over your mind, you can do anything impossible which is not done by anyone. So only things is controlling parameter is most important parameter of semiconductor. Now we are discussing about properties of semiconductor, and I'm taking both as conductor and insulator also in this table. So guys, conductivity is 10 raised to power 2 to 10 raised to power 8, and conductivity unit is Simon per meter. Here 10 raised to power 5 to 10 raised to power minus 6 Siemens per meter, and 10 raised to power minus 11 to 10 raised to power minus 19 Siemens per meter. Resistivity I'll not discuss because resistivity is reciprocal of conductivity. So just you do 1 by reciprocal of conductivity means 1 by conductivity, that is resistivity. Band structure is one of the most important things. So guys, this is actually VB, what I have written, this is valence band, and CB, it is conduction band. What is valence and conduction band, guys? What happens if we talk about conduction band? All the free electrons is found in conduction band. Okay, so this mainly responsible for making reactions with other element. Valence band is outermost orbit electron is known as valence electron, and energy corresponding to valence band is comes under this category. So valence band and conduction band is overlapping. Valence band and conduction band overlapping in the condition of conductors, but in semiconductor there is a gap. Eg is known as forbidden energy gap. No electrons can be found out in this gap. So this is very small in case of semiconductor. This is 1.1 electron volt in silicon, and germanium is 0.78 electron volt. Insulator energy gap is very high. If you see NCRT has given energy gap is greater than 3 electron volt, but let me tell you guys, even energy gap is more than 5 or 6 electron volt. Okay, this is the NCRT data I am giving you. So now current conduction, free electron is responsible for current conduction in conductors. Electron and holes, hole is a concept which is being discussed in a later half of the lecture. Free electrons and holes are responsible for conduction, and there is no need of conduction, there is no requirement of conduction in, and conduction never happens in insulator. Temperature coefficient of resistance, positive for conductors, negative, very important point guys, temperature coefficient of resistivity or resistance is negative for semiconductor. This is the question asked in JEE mains also, and 0 for insulator. Effect of temperature on conductivity, as you increase the temperature, conductivity decreases in case of conductors, increases in case of semiconductor. Again important guys, you increase the temperature, conductivity increases, and that is why you can control the semiconductor, and there is no effect. Bond, which type of bond they forms? Ionic bond they forms covalent bond. And insulator basically like plastic or diamond, they form strong covalent bond. Now guys, electron density, I am talking about number of electrons per unit volume, that is 10 raised to power 29 per meter cube. For germanium and silicon, this is 10 to the power 19 per meter cube and 10 to the power 16 per meter cube, and that is nothing for electron density. Examples: copper, Ag, Au, Na, platinum, mercury, like that. Gold and sodium is also example of this conductors. Now guys, germanium, silicon, cadmium sulfide, gallium arsenide, and indium phosphide. The first two, that is germanium and silicon, they are elemental semiconductor, and cadmium sulfide, gallium arsenide, indium phosphide, they are compound semiconductor. So there are two classification that on the basis of elemental or compound. Wood, plastic, diamond, mica, and glass are the examples of insulators. Now guys, semiconductor can be classified basically into two types: intrinsic or extrinsic semiconductor. Intrinsic means pure form of semiconductor, there is no impurity mixed with it. But actually, what is the problem with intrinsic semiconductor? Actually, they are very poor in conduction. Conductivity is very poor, so not used in many of the application. But extrinsic conductor are very good in conductivity. So actually, how we can make intrinsic to extrinsic semiconductor? We need some doping. You have understand from like some players actually they found guilty in doping test. Doping is process of adding impurity. So guys, if we add some impurity in intrinsic or pure form of semiconductor, extrinsic semiconductor will be formed. And there are two types of impurity we can add. This is trivalent impurity, and this is pentavalent impurity. Trivalent and pentavalent, I hope you can understand that, like boron, aluminium, these are trivalent, and pentavalent is phosphorus and ASSB, antimony, arsenic, this type of things. So intrinsic semiconductor is those semiconductor where we see that number of electrons and number of holes are equal. Here what I'm going to discuss, what is this hole, guys. Suppose a covalent bond is broken. So when a covalent bond is broken, what will happen? Some electron comes out, and when electron will come out, there is a deficiency of electron. So guys, deficiency of electron is basically holes, or I can say deficiency of negative charge is actually holes. So hole is basically deficiency of electron in broken covalent bond. Now guys, what I have taken the structure of intrinsic semiconductor. So intrinsic means pure, so only silicon is all around. You are seeing silicon is tetravalent, so this is the valency of silicon. I'm just making it by another marker. See, this is 1, this is 2, this is 3, this is 4, this is tetravalent, and this is actually combined with all the silicons in adjacent. This is intrinsic semiconductor basic structure. The problem with intrinsic semiconductor that they are poor in conductivity, so mostly it is not used. To increase the conductivity, I already discussed earlier, to increase the conductivity, doping is done. Doping is was process of mixing impurity. So we can add two type of impurity, guys, trivalent impurity and pentavalent impurity. When we are adding trivalent type of impurity, P type of semiconductor we will obtain. Trivalent is boron, indium, aluminium, and trivalent impurity is added to make that I have already written, guys, P type semiconductor. Okay, so that is P type semiconductor. So what is trivalent impurity? I have taken aluminium, guys. You know aluminium is trivalent, 1, 2, 3 electrons are there, but actually it is surrounded by silicon, guys. It is surrounded by silicon, but silicon has 4. So this combines with this combines with this combines with this, but this is actually a hole or a vacancy is there. This is vacancy there which cannot combine with anyone. This is a deficiency of electron, that is hole. So this forms trivalent type of impurity. And in n-type semiconductor, I can say that concentration of holes is greater than concentration of electron. That is, number of holes is greater than number of electrons. As we have seen that here number of electrons and holes is equal to intrinsic Ni, and here number of electrons is less and number of holes is more. So number of holes is more in trivalent impurities. Now guys, pentavalent impurity like arsenic, antimony and phosphorus are examples of pentavalent impurity. It is added to make intrinsic semiconductor to extrinsic or impure, and this forms n-type semiconductor. This forms p-type semiconductor. P means positive type. You can assume that there is no charge on p and n-type. Okay guys, this is just assumption that because this is deficiency, though becomes p-type, and this is excess, that becomes n-type. So here what happens, guys, I'll take phosphorus. Phosphorus has pentavalent compound. So pentavalent is actually the outermost orbit 5 electrons. So this 4 electrons, look it here, this 4 electrons can combine, but this excess electron cannot combine with any other silicon. So this excess of electron making it n-type semiconductor, and here I can write that number of electrons is greater than number of holes. So number of electrons is greater than number of holes in n-type semiconductor. So today I am stopping here. I'm adding some another information in next lecture. So thank you everyone.